Pregnancy and lactation are times of extraordinary physiological transformation, and niacin, vitamin B3, quietly plays a starring role behind the scenes. While it doesn't come with a celebrity status of folate or iron during these stages, niacin is no less essential. In fact, its responsibilities multiply as rapidly as the cells in the developing fetus. During both pregnancy and breastfeeding, a mother's body becomes a biochemical factory, producing more blood, more tissue, more enzymes, more everything. And niacin is right at the center of it all, fueling metabolism, protecting DNA, and helping build the baby's brain one neuron at a time. Niacin's core function is in energy metabolism. It's the precursor to NAD and NADP, coenzymes required for hundreds of enzymatic reactions, most of which are involved in breaking down carbohydrates, fats, and proteins into usable energy. When you're growing a baby, this isn't just helpful, it's essential. Every cell in both the mother and fetus needs a continuous supply of energy to divide, differentiate, and thrive. As pregnancy progresses, maternal metabolism shifts dramatically, adapting to support fetal growth while keeping the mother's own energy levels somewhat intact. This metabolic flexibility depends on a robust supply of NAD+, and by extension, a reliable intake of niacin. But niacin doesn't just help run the metabolic engine, it also helps protect it. One of its most vital roles during pregnancy is in DNA repair and genomic stability. As fetal cells divide rapidly, any DNA damage that goes unrepaired could potentially affect development. Niacin-derived NAD+ activates enzymes like PARPs and sirtuins that detect and repair DNA breaks, silence damaged genes, and regulate oxidative stress. This becomes even more crucial when you consider how sensitive fetal development is to environmental toxins, inflammation, and nutrient imbalances. A well-supported niacin status helps ensure that the developing baby's genetic material is kept intact and protected from harm. Then there's the brain. Fetal brain development is one of the most energy-intensive and nutrient-dependent processes in all of human biology. Niacin supports this process both indirectly and directly by ensuring adequate NAD+ for cellular respiration and neurotransmitter synthesis, and by enabling the body to convert tryptophan into serotonin, a key neurochemical for brain and mood development. Studies have shown that severe niacin deficiency during pregnancy can lead to neural tube defects and other neurological impairments, especially in situations where protein intake is also low and tryptophan, the backup route for making niacin, is limited. While outright niacin deficiency is uncommon in pregnant women in high-income countries, marginal insufficiency could still compromise optimal brain development, particularly when combined with other nutritional gaps. During lactation, niacin continues to be in high demand. The body is now in milk production mode, and that milk contains not only calories but critical micronutrients, including vitamin B3, for the baby. Niacin is secreted into breast milk in biologically available forms that help support the infant's early metabolism and neurological development. The recommended dietary allowance, RDA, for niacin increases during both pregnancy to about 18 mg NE/day and lactation to around 17 mg North/day, with NE standing for niacin equivalents to account for both preformed niacin and tryptophan conversion. While these numbers don't sound massive, the real story is the increased turnover rate of NAD+ and NADP+ during this time. The demands are dynamic, and the body's ability to meet them hinges on consistent dietary intake. Meeting these needs through food is both possible and delicious. Niacin-rich whole foods, like poultry, fish, legumes, mushrooms, and peanuts, can provide steady, safe support. These foods also bring along other nutrients needed for pregnancy and lactation, such as protein, iron, and B6, which enhance niacin metabolism and utilization. For those on plant-based diets, legumes and fortified grains become especially important, along with adequate intake of protein to support the tryptophan-niacin pathway. And for women facing absorption challenges, such as those with digestive disorders or who are dealing with severe nausea, supplements may be recommended under clinical supervision. Ultimately, niacin is a quiet champion of pregnancy and postpartum health. It supports the physical changes of the mother, ensures efficient nutrient use, keeps oxidative damage in check, and helps guide the architectural masterpiece of a developing brain. It fuels life on the cellular level and continues its work as that life begins to grow, thrive, and nurse. So, while it might not make the headlines on prenatal supplement labels, Niacin deserves a seat at the maternal nutrition table for both the vitality of the mother and the brilliance of the baby.